Since we're setting up static routes, let's now give our static route, our default route, going this way for R1. So what we'll do is, it's also a serial 0/0/0 interface. Let's just double check. So we'll do that really quickly on R1. So on R1, we get to global configuration mode and IP route and there is our static route for R1. All right, so that's done. All right, so now comes the fun part. Now we get to configure OSPF on these routers and start playing with OSPF. Now, what I want to do is I want to purposely start by configuring OSPF on the router down here, R2 first. Now, the way OSPF works is the first router that's configured oftentimes becomes the DR, right? And so I'm going to pull this summary route information down now and pull this DR election process up here, and we'll talk a little bit about that. And another thing I want to address is, why do we have a DR, BDR election anyway? Why do we need a designated router and a backup designated router in OSPF? Well, the way link state protocols work is, link state protocols, a link state router, right, or a router running a link state routing protocol, is going to send link state updates and link state information to all other routers in the network, right? So that means that this router is going to send its link states to all these routers, and then this router is going to send its link states to all these routers, and so on and so forth. Now, in a multi-access network, right, where we have multiple routers on the same network, that's a lot of link state packets going back and forth, and it's going to suck up a lot of bandwidth, and it's going to make the routers work harder than they need to, right? So, you know, R3 sending all of its packets to R1, R0, and R2, and an R2 sending all of its link states. So in a multi-access network, a DR, BDR election, what happens is the routers will send their link state packets to the DR, and then the DR will disseminate them to the other routers. And then the BDR is waiting as a backup. So if the DR goes down, then let's say the BDR takes over, and then everybody will be sending their link state packets to the new DR, and then that DR will disseminate the link state packets to all the other routers. So it's kind of like having, when there's multiple routers in a multi-access network, it's a way of disseminating the link state packets so that everybody doesn't have to send to everybody else. So, and then the question becomes, and this is important in the CCNA, Cisco CCNA, is, well, how do you elect a DR and a BDR? Well, it's there's a pecking order. So if you set the router priority number, the router with the highest router priority number will become the DR, and then the router with the second highest priority number will become the BDR, and so on and so forth. Okay, but the router priority number is not configured by default, so you'd have to configure that. So I have that listed here as number 1. Then the second way that a DR and a BDR election takes place is with the highest router ID number. Now, if you don't do anything at all, then this bottom line will take over. This one right here, I'll say C, will take over. And what that is, it'll be the router with simply the highest IP address on any of its interfaces. So, and then the router with the second highest IP address will be the BDR. So R2 here has a 50.2 interface and a 2.0 interface, or a 2.1 interface, because it's 2.1. So the 192.168.50.2 is higher than the 2.1, but this one has a 50.3 interface. So this router has a higher interface than R2. The 3.1 is lower. And then this router, R0, this is the router that we want to be the DR. You can see that we've configured it with a 50.10 address. And 50.10 is higher than 50.3, it's higher than 50.2, it's higher than 50.1, and it's higher than 3.1, 0.1, and all that jazz. So that would be a way that we could influence by setting the highest IP address on R0 to be the DR. But there's a problem. Even though R1 has a 50.1 address and a 1.1 address here, it also has this interface going to the ISP router, which is 200.10.10.253. Right, the 252 network and it's 253. Well, this 200.10.10 network, 200.10.10.252 network, is a higher interface than any of these routers, right? These are all 192.168s. So if you want to go by, if you don't do anything at all, if we don't configure any special configurations, by highest IP address, R1 would win if all of these routers started at the same time, which never happens. Another way you could influence this process is by bypassing just the highest interface IP address and configuring a loopback interface on these routers. And if the loopback interface is configured on any one of these routers, then the loopback interface will be the winner. So the highest IP address on the loopback interface trumps highest interface IP address. And then also what you could do is you could simply set the router ID number by just manually configuring it, and it could show you how to do that. So you could say, I want to configure the router ID number on R0 now because this guy's got this high IP address right here. So I could set the router ID number on this R0 to 222.222.222.222, and then that router ID number will be the highest, will win if all of the routers were to start up at the same time. Okay, but they don't, and that's the other caveat, is that the DR is usually the router that starts up first, and then the router that starts up second will be the BDR, and then those never change until the router is restarted, the router is reloaded, an interface goes down, or you could clear the IP OSPF process. So you could run that command that would clear the OSPF processes and kind of start them over. And then that's another way that you could influence the DR-BDR election. So let's start configuring OSPF and take a look at it. Okay, so I'm going to start with R2 here. So we'll click on R2, and we'll hit enter and enable and conf T, and we're going to type in router OSPF and then the process ID, which will be in this case 1, and there we just started OSPF. Now OSPF needs networks to function with, so we'll say network, these are the networks that are going to participate that OSPF is going to hand out. So it's got the 192.168, and this is router 2, so it's the 2.0 network. And then the opposite of the subnet mask is the wildcard bits. So in this case, it's 0.0.0.255. Well, why is that? Normally, it would be /24 subnet mask 255.255.255.0, and the inverse of that is the 255s become zeros, and the 0 becomes a 255, and you have your wildcard bits. It's essentially the inverse. And then area 0, okay, and there's our first network that's going to participate in OSPF. It's going to be the 2 network, which is the LAN right here, this LAN right here. Now we got to do this network. So this network is the 50 network, so I'm simply just going to up arrow and then change that, and now we have 2 networks participating in OSPF. Now I don't need to send OSPF information out of this interface to the hosts on this LAN. So I need to make this interface passive so that it doesn't send OSPF link state packets out to all the clients. It's okay to send them this way, just we don't need to send them this way. So what we're going to do is I'm going to put a question mark here and look for the passive interface command, and there it is. So I put a question mark, and you can see here I've got some choices here. There's passive interface. So I'll type PAS tab passive interface and then a question mark, and it wants fast Ethernet. Okay, so FA0/1. Can we do that? Yes, we can. So I'm going to hit end, and now that's configured. So OSPF is now functioning on this router, and passive interface, we're not sending link state packets this way. For R3, we'll do the same thing. We'll say enable and conf T for configure terminal, router OSPF 1, network 192.168. I'll do the 50 network this time first, 50.0, and then the wildcard bits Once again, the wildcard bits are the opposite of a subnet mask. And then area 0, the single area OSPF area that we're working with here. In this case is area 0. I'll hit enter, and then I have a misspelling here, so I'll fix that. Typo. Okay, that worked. And now I need to also put in, this is router 3, so we need to also add the 3 network. So I put in network 192.168.3.0, wildcard bit 0.0.0.255, and then area 0, and we're done. Now, I also want to put in the passive interface command, tab completion, FA0/1, because I don't want to send link state packets out to the LAN. Type end, and this is done. Now, we can also see what happened with the DR BDR elections. So we'll say show IP OSPF neighbor to see our OSPF neighbor, and we have achieved an adjacency. You can see here this output that came to the window automatically that said OSPF adjacency change process 1, and then here when we put in the show IP OSPF neighbor command, we can see 50.2 is our neighbor. We can see that it's full adjacency, so the state is full, and you can see that it is the DR. So 50.2 became the DR, even though this router has the 50.3 IP address. It has the highest IP address between the two, but it is not the DR because R2 was configured first. So, so there you have it. So it matters which router is configured first.